Hi guys. I'm going to show you a little bit of an endothermic reaction today. So we've discussed what exo and endothermic reactions are. I hope you can remember them. Today we're going to look at how to do an endothermic reaction, an example of one. So obviously not in school right now, so I'm going to have to do this using just some equipment I've got in the cupboard. So I've got some white wine vinegar and I've got some baking powder, and this should give us a nice reaction. So I'm going to do this as scientifically as possible with the equipment I've got. I'm using a measuring jug here instead of obviously a measuring cylinder. So I don't know exactly how reliable the measurements are. I'm still going to measure it out properly there. So I'm going to take 50 mils, 50 centimetres cubed of vinegar and pop that in my cup. Okay, and then I'm going to measure the temperature. I'm going to stick that in there and leave the temperature to settle just for a moment or two. It's important to do that and also give it a little stir. Try and measure it from the middle of the fluid, okay, or the middle of the liquid that you're measuring, because otherwise you're measuring the temperature of the cup, and if you don't mix it, then there could well be patches that are more or have more or less heat energy in them, or so they're warmer or cooler than other parts, and you want to be as accurate as possible. So my starting temperature is 19 degrees C. Just going to pop that there. I'm going to take 1 teaspoon, which is 5 millilitres of, if we're measuring a liquid, and it obviously depends on the density of the solid that we're using. But I'm just trying to use that so again you've got an idea that I'm trying to be as scientific as possible. So this baking powder's got sodium bicarbonate and sodium carbonate in it, and it should, when you react it with vinegar, release lots of carbon dioxide, so this should fizz. And the reaction that goes on there when it releases that carbon dioxide is in fact an endothermic reaction, so we should see a temperature drop. Okay, so there we go, we're on 19 degrees C. Just check that again. Yes, we are. Okay, and I'll pop my baking powder in there. You can see that there's a reaction going on. You can see because of the bubbles, and we're starting to get a temperature drop. There we go. I'll keep stirring it, make sure the reaction's going to completion. Yeah, temperature's still dropping. We're on 17 degrees C now. So I did this one earlier. I tested it out with pure bicarbonate of soda, or sodium bicarbonate, and I got a much better temperature drop than I'm getting now. I'm still getting a temperature drop though, so we know that it's endothermic. So we know that when this reaction happens, we've got more energy going into the chemicals, okay, than is coming out of them. So it looks about settled now, and the reaction's just about finished. So I'm down to 16 degrees C. Okay, so that is a drop of 3 degrees C. Yeah, so the temperature's dropped 3 degrees C. Now, how do I know that that's accurate? What can I do with this experiment to make it a better experiment? Well, there's a couple of things. If you look at the cup I've got a plastic cup, and plastic's a pretty good insulator, because if you think about what we're trying to do here, we're measuring energy changes. So we need to make sure that there is no energy getting into the system from outside, which it is. Okay, so we're going to try and minimise that as much as possible. So what could we use instead of this? Well, a styrofoam or polystyrene cup we could use, except they're a bit more difficult to find now because they're pretty bad for the environment in actual fact. The other thing that we could do is put a lid on the cup as well, and that would stop energy getting in or getting out, or anything else getting in or out as well. You can see I've got this on a plastic tray. That's actually because the first experiment I did, it all poured over the sides, and I didn't want to make a mess of the lovely coffee table that we've got here. But what we could also do is stand it on a styrofoam mat or a heat-proof mat, something like that, that would insulate it. So it's addition of insulation that's really important there. So you can see what I've done. I've measured out my reactants. I've reacted them. I've measured the temperature of the liquid here, okay, and made sure that the temperature's steady. Once it's steady, and I know that I've measured it from the centre of the liquid, I've added my measured amount of my solid reactant here, and I've measured the temperature as it drops. And when it stops dropping, I know that I've got a temperature drop then. Excuse me. And then I've just been thinking about how I could make that experiment better or more accurate. There is also on the thermometer, you'll not be able to see it from here, and I'm not going to try and hold this up, but you can measure to about 0.5 of a degree with this type of thermometer, because it's either on the line or it's in between the line. If it's in between the line, you could say that it's 0.5, 19.5 degrees C. So we've got an element of precision there as well. Okay, I hope that's been useful. I'm going to set you a few questions on this now that we're done. Okay, I hope you've enjoyed it. Stay safe.